I work on finding planets like Earth, but around other stars. When I was born in 1994, we knew of only 9 planets, the 9 in our solar system. We have lost Pluto since then, and I know it's sad, but we have found over 4,000 planets outside our solar system, or exoplanets, planets that orbit stars other than our sun. We have found exoplanets 30 times the size of Jupiter, disintegrating exoplanets, pink exoplanets, and from this huge variety, we have learned so much more about how planets form and evolve than ever would have been possible with just our one solar system alone. Yet, of these 4,000 exoplanets, few are small and terrestrial like Earth. I work to find more Earth-like planets so that we can finally start to answer questions about where we came from, our mountains and our oceans, our forests and our pet dogs. Are we special and alone, or are the cosmos teeming with life? It's just, Earth-like exoplanets are pretty hard to find. They're small and they're dim. Exoplanets are rarely bright enough that we can see them directly. Instead, we primarily discover exoplanets by measuring the effect they have on the stars they orbit. I use the wobble method to detect exoplanets. We may typically think of planets orbiting around a stationary star, but planets actually exert a gravitational tug on their star as well. Planets are just so much less massive. This tug is much weaker, meaning the star moves a lot less, or just wobbles a little. More massive planets will pull their stars more, less massive planets less. We can measure the speed of a star being tugged by a planet and use that to infer the mass of the planet that must be exerting that tug. An Earth-like planet will move its star at a speed of only 10 centimeters per second. This is the average crawling speed of a Galapagos turtle. So I am here trying to measure a star hundreds of trillions of miles away, moving at the speed of a canonically slow animal. That's why, in my first 3 years, I helped to build Express, one of currently 2 such instruments in the world capable of measuring the signal from a true Earth twin. Through advancements in detector technology, material science, and optical design, Express returns data that is a factor of 10 more precise than previous instruments. But much like how a fine-tip pen can write smaller words, but they'll be harder to read, the Express data is sensitive to the smaller signals of Earth-like planets, but requires innovative methods to interpret. So I am now designing statistical models specifically tailored to this higher precision data to disentangle planetary signals from other sources of noise. The unprecedented precision of Express, combined with these novel data analysis techniques, will allow us to discover more Earth-like planets and finally contextualize this one planet on which we spent our whole lives. Thank you.